Hello and welcome to another language design video. It's been a while since the last one, but to make up for that, we're going to cover two topics today, and those two topics are Gren-in-Gren and the new package manager. So we're going to start off by talking about Gren-in-Gren, or Gig for short. I've never called it Gig, but maybe I'll start to. Gren-in-Gren is usually what it is. So Gren-in-Gren is exactly what it sounds like. It's the Gren compiler written in Gren. Previously, or currently, but also currently, it's written in Haskell. So we're rewriting it piece by piece in Gren. So how does that look like? So the first part of Gren-in-Gren was delivered way back in Gren 04 with the rewrite of the npm wrapper. Now, the npm wrapper was originally some JavaScript that ran for the Gren compiler installed through npm. And what that JavaScript did was to check if you had the correct Gren binary installed. And if you didn't, it would download that binary from GitHub that was correct for the specific version and the specific operating system you were running. So that was like the first production use of Gren in a compiler setting, right? Now in Gren 05, which was released in December, we expanded that wrapper to be a full program that parsed command line arguments. Still not doing a whole lot, right? But but now it's actually part of the compiler. Now, as part of that release, we split the compiler in two. There's now a Gren written front end, which is what you start initially. And then there is a Haskell-based backend, also known as the old compiler, right? So when you start the Gren executable, it will run a Gren program, which will do as much work as it can before it passes off the state to the Haskell backend. And what we're working on now is the next step of that, so that in addition to parsing the command line arguments, it will also check that all the packages you need to compile your program are present on the machine. Now we're going to talk about that a little bit later, but first we're going to talk about why we are doing this gig rewrite. And a lot of this, or the backdrop of this, is that the time that I have available on working on Gren is very limited. I think on average I get between 2 and 4 hours every week, which isn't a whole lot. So it is vital that that time is being spent as efficiently as possible. And what I found is that the situation before Gren-in-Gren wasn't really workable long term. Now, there are several reasons for that, but parts of it is that what I was spending most of my time doing was writing Haskell. And I'm not very fond of Haskell. I'm not very good at Haskell either. And with 2 to 4 hours every week, I'd rather spend time working on Gren than fighting the Haskell compiler, which I did too often. And the second thing is that since I was constantly working on a Haskell program, I didn't really become a good Gren developer, and I didn't get to really test the APIs I was designing or the language features I was designing. Gren as a language was more of a theoretical construct when I wanted it to be like a language that I would enjoy. But how do I know that I enjoy the language if I never get to use it, right? And so this is really what prompted the rewrite. I wanted to work on Gren not only because I'm not fond of Haskell, but also to uncover obvious design mistakes, both in language and APIs, or find bugs in code that shouldn't be left up to my users. So there is this thing where I didn't really enjoy working on the Haskell-based code base, but I also wanted to battle test the Gren compiler and the Gren core libraries. Uh, and the best way to do that is to actually use them on a daily basis, which I can only do if the compiler is written in Gren. Another good thing about it, though, from a theoretical perspective, is that it aligns my incentives with the user. And what I mean by that is, if the compiler is slow, then I have an incentive to fix that because I feel the same pain that everyone else using the compiler would, right? Um, if Gren runs slowly, then I will have a incentive to fix that because that ultimately makes the compiler slow. These sorts of things, right? If there's something that can't be done, then I have an incentive to fix that because I probably need to be able to do those kinds of things in order to finish the compiler. So those are like good things. Now, from a more exciting perspective, uh, another thing that the Gren-in-Gren enables is to have the compiler available as a package, right? That means that people can import the Gren compiler to parse code, to analyze it, to reformat it, to generate code, all these sorts of things. And of course, if there are things that, like if you would like to make a command line application that works just like the command line interface of the compiler, you could do that because you could just include it in your binary. And in that way, you can actually just it's a way of me paying back to the community or providing stuff to the community for people who are building similar programs. And probably the last point is that since Gren compiles to JavaScript, Gren-in-Gren will make the compiler more portable. Currently, we are compiling the compiler to 4 different architectures. Like we compile it to x86 or 64-bit Windows builds, 64-bit Linux builds, and then both Intel and Apple Silicon versions of Mac. But we don't compile any other version of the Haskell compiler. That's up. So if you're using one of those platforms, you have to build the entire thing yourself. If an entire compiler was written in Gren, you could run it on any platform where Node is available, which is most platforms. So that's another benefit of the whole Gren-in-Gren thing, is that it just makes code, it makes the compiler more portable with a low amount of effort. Which is not to say that everything about Gren-in-Gren is great. We now have a more complicated compiler than we used to. Because we now have this Gren front end that has to communicate with this Haskell backend. We have 2 pieces that has to be kept in sync, and those 2 pieces inevitably has to have some overlapping capabilities, right? So now that we're doing package management, the package management's obviously being done in Gren, but whatever that figures out, it has to pass along to the Haskell compiler, right? So you have so currently the way we do it is that we gather all the source code, then we encode that to JSON, send it over to Haskell, which has to decode that from JSON and then make use of it somehow. It's more complicated. It's probably slower than keeping everything in one application, and there are moving pieces. This, of course, in addition to being like a technologically more complex and more slow or slower, it's also harder for new contributors to actually get this set up correctly and understand the moving pieces. Another problem with this, of course, is that Gren and JavaScript doesn't have all the same capabilities as Haskell. So for Gren, for doing the simple npm wrapper, the reason why that took like a full release cycle was because in order to do that, we would have to write the child process API and we would have to write the file system API, right? Now that is ultimately a good thing for people who use Gren, but it's also why writing the compiler is moving slowly, because we have to build the primitives required for a compiler at the same time that we're rewriting things. So ultimately, these things, I'm not saying these are I personally, I believe Gren-in-Gren is a really, really good use of my time, but I can't argue with the fact that Gren-in-Gren makes the overall development of the Grendel language slower, right? Better, but slower. So that's Gren-in-Gren. That's what we're working on right now, and what we will continue to work on for the foreseeable future. Now, currently, we're working on package management. That's the next logical step from command line parsing, right? In order to compile an application, you first have to download all the packages required to compile it. So that's the next logical step. One of the benefits of doing package management is that a lot of the command line commands really only needs package management to work. So when you run gren init, the only thing we need to know is what should the gren JSON look like and what are the latest versions of these packages. And, you know, obviously all the gren package commands needs to know package management. Make needs to know package management. And I guess that was it. Like that, those are all command line commands. And by implementing package management, almost all of them are supported in Gren. So that removes a lot of stuff from the Haskell compiler. Now, we are not just rewriting things. We like to, as we're in a new system, as we're rewriting a part of the compiler, we also like to take a step back and reevaluate how it works and if we can make it better. And the problems with package management, the way it works today, is that it was never really meant to be a permanent solution to begin with. When I wrote the first version of Gren, I did two main things. I changed the name from Elm to Gren, and I had to find some way of having support for packages because I obviously couldn't use the Elm package management. So the way we did that was to simply say that whenever you want to download a package, you're just going to git clone this GitHub repository, and that's going to be your package. The problem with that is that we are forcing people to use Git, and Git is slow compared to just downloading something with HTTP, and we're forcing people to use GitHub, and GitHub is the most used forge in the world, so it's a popular solution. Git is the most popular version control, but that might not always be the case, and every once in a while people don't really want to use GitHub for reasons. So forcing people to use Git, forcing people to use GitHub, these are liabilities, and I'm not convinced that they are good liabilities to have long term. Now, there are many ways of implementing a package manager. The approach that we've taken is really to keep everything the same. So if you didn't know that package management had been rewritten between 0.5 and 0.6, if I hadn't told you, you shouldn't really notice, except that it's faster, maybe. So we're keeping most of the interface the same. But the difference is that packages will now be served from a central web service. This is something that Justin Blake is working on. He's writing the actual web service while I'm doing the compiler related changes. That web service will be written in Gren, and it will do user authentication, and it will host the actual packages. So it will be completely detached from GitHub, and it will be completely detached from Git. Now, the benefit of doing this, of course, is that, since we're hosting things globally, since we're doing a centrally hosted package registry, then we will have global identities. So if you're downloading grenlang/core, you don't have to wonder if it's the correct grenlang/core, right? You don't have to consider if the version of grenlang core from GitHub is the same as the one from GitLab, right? There is one identity called Grenlang, so if you trust that, then you always know that packages with that author is legit. Another benefit is that you can use whatever version control you like, or no version control at all, and you can use whatever forge you like, if at all, right? This gives flexibility to user, and and it also, improves the speed. Since we're not using Git, people can download packages faster, and it will be good. Another benefit of this is that we get to enforce certain constraints. We couldn't actually do this before. So currently, when you're downloading packages with Gren, we are just cloning a Git repo. That doesn't have to be a valid package. So we have this tool called Gren package validate, which will run a series of checks. But that's mostly hygiene, right? That's mostly like you should do that and do what it suggests you to do, but it doesn't prevent you from tagging a version and pushing that to your repository, which in turn doesn't prevent anyone else from trying to install it. But having a central hosted registry of packages allows us to enforce that only valid packages are made available in the registry, right? So those are the benefits of that. Now, of course, there are challenges to this. There's a reason Elm doesn't do this. Elm has a package registry, but it doesn't host the packages itself. And since it relies on GitHub, it doesn't do user authentication, right? So the challenges or the problems with this is that it increases the cost and complexity. We have to host a service. We have to make sure that that service is secure and available most of the time, right? If that package server goes down, then that means that Gren isn't really working well. That's on us now. The other problem, which it's not a problem for me per se, but it's something to keep in mind, is that this moves a lot of power to us, the core team, right? This gives us a lot of power over where to host packages, how those packages should look, which is, this isn't unique to programming languages, but it's power that we have to use responsibly, which is, I guess, interesting. Now, some of the challenges of hosting a centrally hosted registry means that we might have to pay a lot of money for bandwidth. And if the central registry goes down, then people might not be able to work. These are challenges that ideally we'd like to reduce the risk of those things as much as possible. So in addition to hosting a central registry, we're also providing this thing called zero installs. Oh, there we go. Now, zero installs is a concept I believe that I first saw in the Yarn packet manager for Node, which is a concept that when you install a package in your project, you get this artifact that you check into your version control system. And as long as that artifact is in your version control system, you have now installed the package. That means that if you were to switch between branches or clone a new registry, you would get all the dependencies of that project as part of your version control system. So I'm going to show you what that might look like, or what that will look like in Gren. So I hope you can see this. In fact, I might even be able to. Whoop. Here we go. So we have, when you're using the latest compiler, we are going to create a Gren packages folder in your project in the same way that you get a node modules folder, right? And that Gren packages folder is going to contain one file for every dependency in your project. So here you see there's a file called Grenlang core version 601. That is a gzipped version of that package. And like I said, we're going to encourage people to check in this folder into their version control system. And these files serve double duty, right? In the future, when the parser is rewritten in Gren, these files will contain the parsed source code of your project. Currently, they contain the actual source code, but in the future, they will contain the parsed AST of that source code instead. And so when you load these packages, when the compiler loads these packages, it will load pre-parsed code. and it will load the entire package at once, right? Instead of loading individual files. And so it's both a performance improvement, but it's also like a cache. So if you're gonna, when you're using continuous integration server to run tests or whatever, the packages will already be there as part of your version control system. And of course, the benefit to the core team is that if the central package server goes down for a bit, that doesn't matter because you're likely to have the dependencies of your product checked into version control anyway. Yeah. So that's what we're working on for the new package manager, which we hope to release this summer as part of the 25S release of Gren, along with other changes to API, minor changes to API and bug fixes. That's the headlining feature this year. So thank you for watching this video on Gren-in-Gren and the new package manager. I hope it was interesting, and I'll try to not wait too long until the next language design video. If there's something you would love to see a video about, leave a suggestion in the comment section below, and I will keep it in mind when deciding the topic for the next language design video. Thank you for watching.